So this will be our last video lesson for the school year. This is 9.5 on page 420 of your textbook. We will finish up with this lesson, 9.5, and then we'll move on to the end of the year reviews. 9.5 is about mean absolute deviation. So let's work through this together. If you remember absolute value, absolute value is the distance of a number from zero, whether it's positive or negative. So the number 2 is 2 spaces from 0, so it has an absolute value of 2. The number -2 is also 2 spaces from 0 and has an absolute value of 2. So that's kind of what we're working with today. So step 1, find the mean of the data. Okay, we've been doing that where you add up all the numbers and you divide by however many numbers you added. Step 2, we're going to find the distance of each data value and then find that mean, and then find the sum of the distances from step 2 and divide the sum in step 3 by the total number of data values. They made that sound way more complicated than it needs to be. So let's just work through this. You record the numbers of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. Okay, so you have 8 scoops of cereal, and for some crazy reason, because you have too much time on your hands, you decide to count the number of raisins in each scoop. Okay, so you have a scoop with 1, 2, 2, 2, 4, 4, 4, and 5. Okay, so the first thing you're going to do is you're going to find the mean, find the average. So we're going to add all this up and divide it by however many numbers there are. So 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. So 5 plus 4 is 9, plus 4 is 13, plus 4 is 17, 18, 19, 20, 21, 22, 23, 24. And we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8. Because we added up 8 numbers. 24 divided by 8 is 3. So your average is 3 raisins per scoop. Okay, 3 raisins per scoop. Now, we can put this information on a dot plot. And we have numbers from 0 to 6 on our dot plot. Okay. And then we have 1, and then we're just going to put this information on the dot plot. 2, 2, 2, 4, 4, 4, and a 5. Okay, so this is our mean right here because we decided 3 was the mean. And if you look at this information on the dot plot, it's kind of easy to see that this is the middle, or this is the mean, because you've got 3 and 1, 3 and 1. It's kind of just perfect right there in the middle. Okay, so we need to find the distance from the mean, not the distance to 0 this time, but the distance to the mean from each of these numbers. So we have a 1, and that is 2 spaces away from the mean. So we're going to write that as 2. These are each one space away from the mean. So this is one space away, and we have 3 of them. So we have 3 that are one space away. And then 4, these are also one space away. And there's 3 of them. And then this 5 is, again, 2 spaces away, okay? So basically what we've done is we've come up here, and in absolute value, we were trying to find the distance to 0. In absolute mean, we're trying to find the distance to the mean. So this is 2 spaces from the mean, 1 from the mean, 1 from the mean, 1 from the mean, 1, 1, 1, and 2 from the mean. So that's where we get these numbers from down here. So now we're going to add all of these numbers, and it's 2, 3, 4, 5, 6, 7, 8, 9, 10. If you add all those up, it's 10. Oopsie, 10. And then we're going to divide it by how many numbers we have. And if you do 10 divided by 8, you get 1.25. So 10 divided by 8 is 1. Gotta add our decimal. $1.25. So this is raisins per scoop. Okay, so the data values differ from the mean by no more than an average of 1.25. Okay, so basically what they're saying is any number you got originally, the average away from the mean is 1.25. That's it. So here we have 3 that are 1 away and 1 that's 2 away, 1 away, 2 away. So it would be crazy to have a number that was like, oh, the average is 6 away, because you can see in this cluster here that they're not that far away. Okay, so let's try another one. Okay. So in example 2, they give you 5, 8, 8, 10, 13, 14, 16, 22. 5, 8, 8, 10, 13, 14, 16, 22. Okay. So if we add these up, we get 5 plus 8 plus 8 is 16, plus 10 and 13 is 23, plus 14 and 16 is 30, plus 22. I'm just kind of combining them as I go to have less numbers to have to add. So now we've got 30 and 22, that's 52. 16 and 5, 21. Okay, so now 21 and 23 is 44. And now that's 96. 96 divided by our original amount, 1, 2, 3, 4, 5, 6, 7, 8. And if you do 96 divided by 8, you get 12. So the mean for this set, for this data set is 12. And again, all I did was add these up. Now I could have just written them all 5 plus 8 plus 8 plus 10 plus, but I just kind of went through and started 8 and 8 is 16, 10 and 13 is 23. Just kind of started combining them down so I had bigger numbers to work with. And then 96 divided by 8 is 12. Okay, so our mean is 12. So now we're going to show these on a dot plot. And we have numbers from 5. We have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so we went all the way from 5 to 22 on our dot plot, and we've decided that the mean is 12. So this is super important, so I'm just going to star this because that's our mean. So now when we plot these numbers, then we're going to go back and count how far away they are from the mean. So here's a 5. We had 2 8s. We had a 10, a 13, a 14, a 16, and a 22. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we go back and we figure out how far this 5 is from the mean of 12. Well, it's 1, 2, 3, 4, 5, 6, 7. So we're going to rewrite that as 7. Plus 8 is 1, 2, 3, 4 from the mean, and there's 2 of them. 10 is 2 from the mean. 13 is 1 from the mean. 14 is 2 from the mean. 16 is 1, 2, 3, 4 from the mean. And 22 is 10 from the mean. Okay, so again, we're just counting how far these are from the mean this time. 10 plus 4 is 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 7 would be 34. Divided by still 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. Now remember, even if I start combining these down here, I still have to divide by my original amount of numbers. And 34 divided by 8, 4 times 8 is 32. 4.25. So the average distance of any of these values from the mean is 4.25 spaces away. Obviously, you have some that are closer than 4.25 spaces away, but that makes up for this guy who's way out here. Okay, so all you're doing is finding out the average amount of spaces they are from the mean. That's it. Okay, last example. Last example says, 2 smartphones show the number of runs allowed by 2 pitchers in their last 10 starts. This is on page 421, example 2. Okay. Find the mean, the median, and mean absolute deviation for the number of runs allowed for each pitcher. Okay, so they want us to find the median. And when we're doing median, we have to make sure things are in order from least to greatest. So, order the runs allowed by Mendoza. And you can see on these smartphones over here on the left, Mendoza's values are the top, Rodriguez's values are the bottom. We're just going to work with Mendoza's right now. Okay, so his in order are 0, 0, 0, 2, 4, 4, 5, 6, 6, 8. Okay? So these are the runs that he allowed in his last 10 starts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see he had 3 games where he didn't allow any runs, and then one where he had 8. So that's a big switch, big gap. Okay, so the median, this would cancel. 0 would cancel with 6, 0 is 6, 2 would go with 5, and then you've left with 4 and 4, which the median would be right here in the middle of 4 and 4, which is 4. So your median would equal 4, okay? Remember where you're just crossing off from side to side. Now, we have to find the mean, so we add all these up, okay? Now I could rewrite it 0 plus 0 plus 0 plus 2 plus 4, but I'm just gonna add I'm just gonna pretend I know there's addition signs there. And 0 plus 0 plus 0 is just 0, plus 2, so 2, plus 4 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 6 is 27, and 27 plus 8 is 35. So if you add all these up, it's 35 divided by 10 starts. Now, you may think you only need to divide by 1, 2, 3, 4, 5, 6, 7. But that isn't true because these zeros count, even though they don't add value to the total, they still count as numbers we need to divide by. So we're dividing by 10. And we know that when we divide a number by 10, it's like moving the decimal 1 place to the left. So that's 3.5. Okay, so that's the mean. So the average number of runs that he allowed per game was 3.5. Okay, now let's find the mean average deviation. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, our mean is actually right here at 3.5. And I'm going to star it. And then we have 0, 0, 0, 2, 4, 4, 5, 6, 6, 8. Okay. These zeros are how far from the mean of 3.5? They're 3.5. So now we would write them as 3.5, 3 plus 3.5 plus 3.5 plus this 2 is 1.5 away, so plus 1.5 plus 4 is half away, so plus 0.5 plus 0.5 plus a 5, which would be 1.5 away, 1.5 plus 6, which would be 2.5 away. So, and there's 2 of those. And then 8 would be 1, 2, 3, 4.5. Now, you may notice we have all these 0.5s. So what I like to do is I like to go through and start combining again. 0.5 and 0.5 is 1. 3.5 and 3.5 is 7. 3.5 and 1.5. So 3 plus 1 is 4. A half and a half. These would be 5. So I'm just kind of combining to get rid of those 0.5s everywhere. 2 plus 1 is 3, and a half would be another, which would be 4. 4 plus 2 is 6, and then a half and a half would make it 7. Whew, that's much better. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, plus 7 is 24. Now remember, we're still dividing by 10 because we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. We just combined them to get rid of all those halves. Okay, so now we have 24 divided by 4, and we know that dividing, or 24 divided by 10, and we know dividing by 10 is like moving the decimal in one place, so it's 2.4 is the mean average deviation, or MAD. So what that means is, on average, the distance from the mean is about 2.4 spaces away. Okay, and that's it. So there are several steps, but it's all stuff we've done and all stuff that we know how to do. We just have to keep remembering the steps. So step 1, add up all the numbers, divide by however many numbers you had to find the mean. Dot plot it, label the mean. Then go back and put your numbers on the dot plot and then figure out how far they are from the mean. Write down each absolute value, add them up and divide, and you have your MAD. Okay, so I'm going to keep this assignment short and sweet, and you'll find it on the portal. I'll just assign the numbers on the portal there. Let me know if you have any questions. I'm also going to attach a video to help you. All right, I hope you have a great day. This won't be due until Friday, but this is what you should work on Monday to stay on track. Bye.